Hello students, in today's lecture we are going to solve NCERT exemplar problems on laws of motion, and questions are 4.1 to 4.5, 4.8, 4.19. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. Learning objective: by the end of this lecture you will able to solve questions on laws of motion by applying concepts of law of inertia and Newton's equations of motion using proper reasoning and calculations. So in today's lecture we will solve exemplar problems on laws of motion. There are total 42 questions in this exercise. We are going to cover 7 questions, and that is 4.1 to 4.5, 4.8 and 4.19. So question is, a ball is traveling with uniform translatory motion. This means that what? So we have a ball and ball is traveling with uniformly translatory motion. So given options, option A is it is at rest. Option B, the path can be a straight line or a circular, and the ball travels with uniform speed. Option C, all parts of the ball have the same velocity, magnitude and direction, and the velocity is constant. Option D, uh, the center of the ball moves with constant velocity and the ball spins out its center uniformly. So here you have to find out the correct meaning of uniform translatory motion with the using of the options. Please solve this question. You have some time. Let's see the solution of this question. So the correct option is C. All parts of the ball have the same velocity. If we talk about the velocity, so there is a magnitude and direction. So same velocity and velocity is constant. Solution. So the situation is shown in the below diagram where a ball is in uniform translatory motion. So suppose we have a ball like this, and this ball uh, move on a horizontal surface with velocity v. So we can say in uniform translatory motion, according to question, ball is traveling with uniform translatory motion. So we can say in uniform translatory motion, all parts of the ball, listen carefully, all parts of the ball moves in the same direction. That is a straight line in forward. Moves in the same direction with same velocity. If we talk about the in a ball, there is so much parts. All the parts of the ball moves with same velocity and same direction. So if we talk about the same velocity, so it will be magnitude or direction. So ball moves in with same velocity in magnitude and direction and this velocity is constant. So this is the meaning of uniform translatory motion. Clear? A meter scale is moving with uniform velocity. We have a meter scale and meter scale moving with uniform velocity. So it means what? So this implies given options. Option A, the force acting on the scale is zero, but a torque about the center of mass can act on the scale. Option B, the force acting on the scale is zero and the torque acting about the center of mass of the scale is also zero. And C option is the total force acting on it need not be zero, but the torque on it is zero. Option D, neither the force nor the torque need to be zero. So here you have to find out the correct meaning of the uh, when a meter scale is moving with uniform velocity. Clear? So you have some time to solve this question. After that, we will provide the solution of this question. Think about it. I hope uh, you have solved this. Let's see the solution. So the correct option is B. The force acting on the scale is zero, and the torque acting about center of mass of the scale is also zero. This is the correct option. Solution: given meter scale is a moving with uniform velocity. This is given in this question. Meter scale is an instrument that is used to measure the length of any material. We know that Newton's second law of motion. So that is net force is equal to rate of change of momentum, and this is the NCERT equation 4.5. So this is the mathematical form of Newton's second law of motion. So using the Newton's second law of motion, we can solve this question. So we have equation of force in terms of momentum. So net force is equal to rate of change of momentum. So here momentum is mass into velocity. So we substitute the value of P here. So it will be d mv upon dt. So this is the Newton's second law of motion in terms of mass and velocity, or we can say in terms of momentum. So here mass is a constant quantity, so it comes outside. The remaining term is dv upon dt. So F net is equal to m into dv upon dt. So this is just mathematical calculations. According to question, meter scale is moving with uniform velocity. It means velocity is constant. If the velocity is constant, so the next force that is applied on the meter scale should be zero. So we can say F net equal to 0. As all part of the scale is moving with uniform velocity and the total force is 0. Hence the torque will also be 0 because there is a no rotation. Here all part means all part of the scale means complete scale, not a pieces of the scale. A complete scale is moving with uniform velocity. Clear? So torque will also be 0. A cricket ball of mass 150 gram has an initial velocity, this one, u equal to 3 I cap plus 4 j cap meter per second. This is initial velocity, and final velocity v equal to minus 3 I cap plus 4 j cap meter per second. This is the final velocity. After being hit, the change in momentum, that is final momentum minus initial momentum, is what? It means in this question you have to find out the change in momentum, and the formula of the change in momentum is also given here. Final momentum minus initial momentum. We know momentum is mass into velocity, so we have a mass, that is 150 gram, and velocity, so initial velocity and final velocity both are given. So you need to just find out the change in momentum. Given options: option A 0, option B minus 0.45 I cap plus 0.6 j cap, option C minus 0.9 I cap plus 1.2 j cap, and option D minus 5 I cap plus j cap. So which option is correct? You have to find out the correct option. Clear? Please solve this question. You have some time. Let's see the solution of this question. So the correct option is C. The change in momentum is minus 0.9 I cap plus 1.2 j cap. Solution. So we know the given quantities, that is initial velocity is equal to 3 I cap plus 4 j cap meter per second, whereas the final velocity is minus 3 I cap plus 4 j cap meter per second. So we have an initial and final velocity. Now the mass of the cricket ball, that is 150 gram. The important point here is this: the mass is given in gram, and we need to convert this gram into kilogram. So just divide by 1000. So 150 gram, when we convert into kilogram, it will be 0.15 kg, because kg is the SI unit. So this is the mass of the ball. Now we know that the change in momentum, that is delta P, is equal to final momentum minus initial momentum. So this is the formula to calculate the change in momentum. Final momentum minus initial momentum. Final momentum means mass into velocity, means final velocity, minus initial momentum. Initial momentum means mass into initial velocity. So we have a final velocity, we have a initial velocity. and we have a mass that is 0.15 kg. Just substitute the value in the formula and you will be get the change in momentum. So final momentum is mass into velocity and initial momentum is mass into velocity. The important point here is this: both are the velocity, but here we represent final velocity and you represent initial velocity. Remember that. Clear? So now we are going to solve here change in momentum. So solving for delta P. So delta P is equal to mass is we have taken common. So final velocity minus initial velocity. So just substitute the value of quantities. The mass is 0.15 kilogram. Final velocity is given, that is minus 3 I cap plus 4 j cap. Here this is the final velocity and the initial velocity is 3 I cap plus 4 j cap. So just substitute the value of initial velocity. Now the remaining term is mathematical calculations, that's C. So change in momentum is equal to 0.15 into, so when we open the bracket it will be minus 3 I cap minus 4 j cap minus 3 I cap minus 4 j cap. Yes or no? When we open the bracket, so here minus 3 I cap minus plus minus 4 j cap minus 3 I cap or minus plus minus 4 j cap. Clear? So change in momentum is equal to 0.15 minus 3 I cap minus 3 I cap is equal to minus 6 I cap minus 4 j cap minus 3 I cap is equal to minus 4 j cap minus 4 j cap is equal to minus 8 j cap. So this is the change in momentum after the addition of these terms. So 0.15, this is the mass, and when we multiplied 0.15 with minus 6 I cap, it will be this one, 0.15 into 6 I cap plus 0.15 into 8 j cap. Here minus 6 I cap minus 8 I cap. So here we taken common minus sign. So it will become this. Now after addition multiplication, when we multiplied 0.15 into 6, so it will be 0.9 I cap, and when we multiplied 0.15 into 8 j cap, it will be 1.20 j cap. So this one minus 0.9 I cap plus 1.20 j cap is the change in momentum which is asked in this question. Clear? So a cricket ball, this is the third question. So we have next question. In previous problem, that is third question, which is this one. In previous question third, the magnitude of the momentum transferred during the hit is what? So in this question you have to find out the magnitude of momentum, which is we calculated in the previous question, and the question is this one. Got it? So given options, option A is 0, option B 0.75 kilogram meter per second, option C 1.5 kilogram meter per second, and option D 14 kilogram meter per second. So you need to find out the magnitude of momentum. So you have to find out the magnitude of momentum. Please find. You have some time to solve this question. Let's see the solution of this question. The magnitude of the momentum. So, the correct option is C, 1.5 kilogram meter per second. Solution. By the previous solution, the change in momentum, that is delta P, is equal to minus 0.9 I cap plus 1.2 J cap. Yes or no? This is the change in momentum. So the magnitude of momentum, the magnitude of change in momentum, delta P, is equal to mode of delta P. If we want to calculate the magnitude of any vector quantity, just find out the absolute value, magnitude value. So this is mode of delta P. Now here question arises, how we can calculate the mode of delta P. The formula is mode of delta P, or we can say magnitude of delta P, is equal to under root mode of px square plus mode of py square. Here px is this one. When we compare with I cap means along x-axis, j cap along y-axis. So px is 0.9 and py is 1.2. So when we substitute the value in this formula, we will get the change in momentum. So that is mode of p is equal to under root px is 0.9, so it will be 0.9 whole square plus py is 1.2, so it will be 1.2 whole square. So when we calculate this term, we will get the delta P, mode of delta P. So mode of delta P is equal to under root 0.81. When we squaring 0.9, it will be 0.81. And when we squaring 1.2, it will be 1.44 after squaring. So delta P is equal to, when we add under root 0.81 plus 1.44, it will be under root 2.25. So under root 2.25 means 1.5 kilogram meter per second. Clear? So this is the magnitude of the change in momentum. The important point here is this, the unit is kilogram meter per second. Listen carefully. We know momentum is mass into velocity. The unit of mass is kilogram, unit of velocity is meter per second. So the unit of momentum will be kilogram meter per second. So it will be this one, 1.5 kg meter per second square, meter per second. This is the final answer. Clear? Conservation of momentum in a collision between particles can be understood from what? Given options. Option A, conservation of energy. Option B, Newton's first law only. Option C, Newton's second law only. Option D, both Newton's second law and third law. So which option is correct? Or we can say, how we can understand the conservation of momentum in a collision between two particles. So please solve this question. You have some time. Let's see the solution of this question. So correct option is D, both Newton's second law and third law of motion. Solution. So there is a term, and that is thinking process. Means how we can solve this question. So here, for solving uh, this question, firstly we think about it. So for conservation of momentum, we have to see whether net external force is acting on the system or not. Let's see. So we know that for a system, from Newton's second law. So Newton's second law is the net external force is equal to rate of change of momentum, dp upon dt. So the condition is, if external force is zero, if the external force F external is equal to zero, so in that case dp equal to zero. So if dp equal to zero, it means the momentum is constant from this relation. So next, hence the momentum of a system will remain conserved if external force on the system is zero. It means if we have momentum net force x external on a system is equal to zero, so we can say the momentum of that system should be constant. Momentum of that system should be constant. So we can say this is conservation of momentum. In the case of collision, if we talk about the collision, in the case of collision between particles, equals and opposite forces will act on individual particles by Newton's third law. Hence the total force on the system will be zero. Why total force on the system will be zero? Because the forces that is act on the particles is equal and opposite. The important point here is this: we should not confuse with system and individual particles, as total force on the system of both particles is zero, but force acts on the individual particles. It means what? It means the net force on the system should be zero, but there is a force which is act on the individual particles, not on the system. On the net force on the system is zero, but there is a force that is acting on the individual particles. So don't confuse. Clear? A body moving with mass 5 kg is acted upon by a force F equal to minus 3 I cap plus 4 j cap Newton. So this is the force which is acted upon a mass. If its initial velocity at t equal to 0 is 6 I cap minus 12 j cap meter per second. So this is initial velocity. The time at which it will just have the velocity along the y-axis is what? So here you have to find out the time. The given options: option is never, option B 10 second, option C 2 second, and option D 15 second. This is a simple question. Please solve. You have some time. Let's see the solution of this question. So the correct option is B, 10 second. Solution: given mass is 5 kg. This is the mass of the body. And acting force, that is F is equal to minus 3 I cap plus 4 J cap Newton. And the initial velocity at t equal to 0 is 6 I cap minus 12 J cap meter per second. So this is initial velocity. So we know Newton's second equation, Newton's second law of motion. Second law of motion, that is F is equal to ma. So A will be force upon mass. So we have a force, that is minus 3 I cap plus 4 J cap Newton. So just substitute the value of F and substitute the value of M. So it will be A is equal to minus 3 I cap plus 4 J cap divided by 5 meter per second square. So this is the acceleration. Now from equation of motion, that is V is equal to U plus AT. This is the first equation of motion, where V is the final velocity, U is the initial velocity, A acceleration, and T time. So in this question, we know the value of acceleration. This is this one. Time we need to find out, and U initial velocity is given and final velocity is 0. Now here question says time at which it will just have a velocity along the y-axis. Along the y-axis, it means the x components should be 0. So just substitute the value of U, A and T. So it will be V is equal to 6 I cap minus 12 J cap plus acceleration is minus 3 I cap divided by 5 plus 4 by 5 J cap into T. T is the time. So further, for velocity to be along the y-axis, this is given in the question. Velocity to be along the y-axis, the x component must be 0. So we can say the velocity along x equal to 0. So solving for t, so it will be when we substitute the value of vx is equal to 0, so 6 minus 3 by 5 into t equal to 0. So 6 equal to 3 by 5 t. So t equal to what? 5 into 6 divided by 3. So 5 into 6 is 30 and divided by 3 is what? T equal to 10 second. So 10 second is the time at which we'll just have a velocity along y-axis. Clear? The question is, a person driving a car suddenly applies the brakes on seeing a child on the road ahead. If he is not wearing seat belt, he falls forward and hits the head against the steering wheel. Why? So in this question, you have to find out the reason why he falls forward and hits his head against the steering wheel. Think about it. You have some time. Let's see the solution of this question. So, in this question, we have to find out the reason why he falls forward and hits his head against the steering wheel. Solution. This situation, which is given in this question, demonstrates Newton's first law of motion. Newton's first law of motion, or we can say law of inertia, which states that an object tends to maintain its state of motion unless acted upon by an external force, according to law of inertia. Yes or no? Particles wants to stay at rest if they have rest at rest condition, unless acted upon by an external force. So when the car is moving, both the car and the driver are traveling at the same speed, because the driver sitting in the car na, so both car and driver are traveling at the same speed. When brakes are applied, the car comes to a sudden stop. Why? Due to friction between the brakes and wheels. However, the driver's body continues to move forward at the original speed due to inertia. So this is the reason. Driver's body continues to move forward. The reason is inertia. Without a seat belt, seat belt to provide restraining force, there is nothing to stop the driver's forward motion. So there is only component, that is seat belt. Seat belt provide a restraining force. So we can say the driver's body continues its forward motion unless it encounters an obstacle. Obstacle here is the steering wheel. The force of impact between the driver and steering wheel can cause injury. When his head falls on the steering wheel. A seat belt prevents this forward motion by providing the necessary restraining force to keep the driver in a place. This is why seat belts are essential safety devices in vehicles. Yes or no? The entire scenario illustrates the practical importance of understanding and applying Newton's second law of motion vehicle safety design. So this is the main reason. I hope you understand it. Thank you for your attention.